When researching what we wanted our arcade cabinet to look like, we looked at old-fashioned models such as this one and came up with our own spin of it.
So this is the 3D model of our arcade cabinet that we made before we started building so we could visualize what our designs look like. We had the designs with dimensions sketched onto them and everything on paper, but we wanted to see what a 3D version would look like before we started cutting. So we made this design, which shows our dimensions based on scales, as well as where we're cutting the buttons, where we're cutting the joystick, where we're cutting out the monitor. And that's basically our final design right here.
Here we have our control panel that we built by drilling holes into a sheet of wood and using a jigsaw to cut out a square hole for the joystick. Next, we built the entirety of the arcade cabinet, and I think it came out pretty well. All of our dimensions worked out well because we measured everything properly the first time. Lastly, we covered in a coat of spray paint so that it would all look nicely finished for our final product.
Okay, so the first algorithm that we used was for the game map. So you can see here that the zeros represent places where Pac-Man cannot go, and the ones represent places where he can go. And what we used was a simple if statement that placed blocks depending on if there was a 0 there or a 1 there in the map. So the next algorithm is for the ghost's movement. So the dx represents the difference in the x position between the ghost and Pac-Man. dy represents the distance between in the y direction between Pac-Man and the ghost. So what we have is a bunch of if statements that determine the ghost movement depending on those distances.
Here we have our early stages in the map for Pac-Man, followed by the early movement of Pac-Man using the control system. Then we implemented the joystick and buttons, and here's our final product.
Okay, so one of the issues we ran into with building the arcade machine was the actual box, and so we had to build a support to elevate the monitor and make it strong enough so that it could support the weight of the monitor with just using the plywood that we had. So what we did is we added some joints in and then created a small platform across those joints. And then to add even more support, we put a support beam directly in the middle so that it would hold it up and not fall while being in use.
We also ran into an issue of the buttons and joystick not working. We tried to fix the issue by updating the drivers in our computer, but we eventually decided to connect the wires up to a Raspberry Pi to bypass the circuit board for the microencoder.
All right, so our project fared around sixth place in the competition with 80 points out of 100, but before the presentation to the judges, we had a slight mishap where some of the wires were ripped out of the project because someone tripped over it. But overall, I think it was a good time.
If we could do it over again, we would definitely start earlier so we could fix several problems, like the circuit board breaking the day before our presentation.
Although our group worked diligently throughout the semester, I would definitely give the advice not to procrastinate, and you can never finish too early because you can always have problems that'll push back your expected finish date way further than you'd expect.
Some advice for freshmen coming up into Engineering 101 is to utilize resources because with the craft space, the ECE makerspace, and more, there's a lot of resources that you can use like free wood supplies, soldering, and just tools that will help you complete your project in an effective manner.